This is wrong. This part is not appropriately designed to be mass-produced with 3D printing. It has a number of key issues, but beyond that, it's just weaker. We're gonna go ahead and show you how to make a part that is equivalent, but way stronger without using more weight and can be made way more affordably with mass production 3D printing. So what are the issues with this? This is a standard sort of a truss beam or anything along those lines. So trusses are super common and they're super strong for the amount of material that they use. But there's a number of issues with this. Number one, it's printed like this, which is an issue. Number two, you cannot print it vertically, otherwise all of these features will just be too fragile. But you have these through holes which can catch somebody's finger or just collect dust and dirt. None of it is really ideal. This is an artifact of physics of the right way of designing something for minimal material. But it is also an artifact of how it has to be produced. Many people will cut out ribs and cut out trusses and stuff inside of an injection molded part in order to save material. But in printing, that's not necessary. You don't have to make a bunch of cavities to save material. You can just get the strength feature and put it inside of your part. So let's look at the very first issue. First of all, this is a really complex first layer. There are sharp corners right there. It's printed down on the print bed. If you're using a performance material, it's gonna warp all over the place. So the first thing that you can do is just go ahead and give it a backing plate. Now you have a very simple first layer that the rest of it can grow up from. You get the same functionality plus the benefit of a shear plate, and the first layer is made simpler so that it can be made more cheaply. This is really, really important. You do not want an expensive first layer because this will increase your cost of the parts. Also increases the opportunity for defects because when the first layer is complex, this can warp or side extrude or whatever, and any single defect there will ruin the entire part. Way less chance for defects on this. But now this is kind of a waste. You get kind of a cool pattern out of it, but it's really not that useful. And ultimately, when you look close at it, where is the strength going to come from? It's going to come from the walls around those triangles. Well, if it comes from the walls around the triangles, why not just do that? Why design the trusses into it? Why not just make it a solid part and just have the walls inside of there? You can do this. You do not need slicer settings or anything else. In fact, it's best to never rely on slicer settings for anything, but you can still get the same functionality. So what I did was I designed this. No, this is not just a solid infill block. You can do that, that's okay. Making it solid is totally all right because it has a lot of the same functionality as this, and we just use a lower infill inside of that. But again, you're relying on print setting. This actually has this inside of it. Let me explain. What I went ahead and did was instead of designing the truss with a backing plate as you normally would, what I did was I made a solid brick and then I cut small 0.2 millimeter holes into it, which lay out the truss pattern. Now that induces walls inside of the part, and then if you just don't have them stick out the side, you now have a solid piece. This looks really great. You have a nice place that doesn't catch a whole bunch of bugs and stuff, but inside you have all the walls aligned where you want them. And all the other space is just low infill. So we could basically print this with 0 infill percentage, but it would be stronger than this. And you have a nice clean total surface. This is a superpower of 3D printing because this type of embedded geometry, these micro features, has never been possible to do before, but 3D printing lets you do it. So now you can create a part that is as simple as it can be, but inside of it, there is all of this complexity that is able to create strength and create reliability, but now you don't have to look at it or have to deal with the pinch points and all the other issues that come with this, or the manufacturability. Because these holes, these layers, all this kind of stuff can be done in any orientation as well. Because a brick can be printed in any orientation. You no longer have to deal with overhangs or layer orientation. This part just works universally, and because you've cut those small slats into it, strength appears where you want it. So this is a great way to design a part for mass production printing without having to rely on downstream things being just tuned your way. The reason we care about this is a lot is because we run a print farm where somebody can get a hold of 1,000 machines to run for their business. The main way people do this is through teleport, where they will upload a file of whatever their model is, and then when they get an order, we will print it and ship it for them. It plugs right into their Shopify, right into their Etsy, wherever it needs to be, so that whenever they get an order, it is printed and shipped. That way they don't have to build a print farm. They can focus on designing awesome products and creating really unique solutions that were never possible before, but not have to deal with tariffs or changing out filament in the middle of the night or knowing how to build out a really large automated print farm. Using teleport is like having 1,000 machines in your pocket. Whether you make one part tomorrow or 1,000, it can handle both of them. And if you're designing the parts right, you get all kinds of cool functionality without adding cost, and knowing that it's just as strong and just reliable as anything else that you would ever do. So if you want to learn even more tricks about how to design for mass production printing, go ahead and subscribe down below. And if you need 1,000 more printers for your business, go ahead and check out Teleport over at slantpod.com.